afternoon to everyone. So this is M.Devipriya, Assistant Professor in Mathematics Department. Today we are going to see about the statistical numerical methods for the regulation 2021. The subject code of statistical numerical methods is MA3251. So today we are going to see about Unit 1, that is testing of hypothesis. So, before going to the testing of hypothesis, we need some definition. What is statistics? What is the population? And what is the difference between the population and sample and the hypothesis? What is the meaning of hypothesis? The first statement is, what is the definition of statistics? It is a branch of mathematics dealing with the collections, analysis, interpretation and presentation of masses of numerical data. So this is the definition of statistics. As we now all know that what is statistic is. The next definition is what is the population. In statistics, a population refers to all the members of a group. A population can be larger or smaller depending on what you are interested in studying. For example, the population could be all the residents of a Germany. We will take some example, which is in 2017. Was estimated to be about 83 million people, or all the freshmen in a certain high school, which can range from a single person to a couple thousand, depends on the school. So we need, what is the population is, that is the total area, that statistics what we are going to take, that is our population. And the difference between population and sample, that is no matter how large or small a population may be. A sample refers to a subset or a part of that population. For example, if the number of freshmen in a high school, the class is 100, we may choose to study only 45 of the students. That is a sample. That is, for example, if you take the students completely studying in a college, under that the sample is a particular department students. So that is the sample. So next one is hypothesis. A hypothesis is an assumption about a population parameter. This assumption may or may not be true. Hypothesis testing refers to the formal procedure usually by the statisticians to accept or reject statistical hypothesis. So the next one, what is hypothetical testing? A hypothesis is an assumption that a population parameter, it is a statement about the population that may or may not be true. Hypothesis testing aims to take a statistical conclusion about accepting or not accepting the hypothesis. Under that, there is two hypotheses. One is the null hypothesis and the other one is the alternative hypothesis. The null hypothesis is, it is a statement about the population that either is believed to be true or is used to put forth an argument unless it can be shown to be incorrect beyond a reasonable doubt. The alternative hypothesis is, it is a claim about the population that it contrary to H0, and what we conclude is we reject the hypothesis. The next one is, so these are the basic for testing of hypothesis. So here we will choose a one-tailed test or two-tailed test for our conclusion. So this represents the two-tailed test. We will consider both the regions left and right, and if it is a one-tailed test, we will consider only the left region, and if it is a one-tailed test right, we will consider only the right set. So these are the standard values for the critical values for the level of significance. For two-tailed test, for 1% level of significance, for two-tailed test for 1% level of significance, the standard value is 2.58, and for 5% level of significance, the standard value is 1.96, and for 10% level of significance, the standard value is 1.645 for two-tailed test. Where it is for right-tailed test, the 1% the standard value is 2.33, for 5% it is 1.645, and for 10% it is 1.28. And if it is a left tail test, the standard value is minus 2.33 for 1% level of significance, and for a 5% level of significance it is Z is equal to minus 1.645, and for 10% level of significance it is minus 1.28. So now under this we are going to see about the large samples and small samples. Under large samples, the first test is test of significance of single mean. So let us see some points to test the test of significance for single mean. That is the standard error of mean of a random sample of size n from a population with variance sigma square is sigma by root n. Thus, if you want to test whether the given sample of size n has been drawn from the population sample with mean mu, we set a null hypothesis H naught, that is, there is no significant difference between the sample mean x bar and the population mean mu. So, for that, the test statistic what we are going to use here is Z is equal to x bar minus mu divided by sigma by root n. So, this is the test static we are going to use it. So, under that we will see some problems here. So, the first problem is the mean breaking strength of the cable supplied by the manufacturer is 1800 with a standard deviation of 100. By a new technique in the manufacturing process, it is claimed that the breaking strength of the cable has increased in order to test this claim. A sample of 50 cable is tested and it is found that the mean breaking strength is 1850. Can we support the claim at 1% level of significance? So here the given value of n is 50 and our population mean mu is 1800 and our standard deviation is 100 and the sample mean x bar is 1850 and the level of significance is 1%. Okay, so now first we have to fix our null hypothesis, that is H naught. So H naught here they given it as mu is equal to 1800. We are taking the statement as it is H naught such that mu is equal to 1800. Okay, and next step is you have to fix the alternative hypothesis. Under alternative hypothesis, they have given that mu is equal to 1800. Now we are using a one-tail test. We are considering it as mu is greater than 1800. So we are going to take our right tail one tail test. Okay. So next the alpha level of significance is 1%, and the fourth one we have to check a critical region. The critical region here the standard value is Z alpha is equal to 2.33. So next the next step, the test statistic, that here for the formula is Z equal to x bar minus mu divided by sigma by root n. We know the values of x bar, that is 1850 minus the value of mu is 1800 divided by the value of sigma standard deviation is 100 divided by the value of n is 50. So root 50 is equal to, so while calculating this we will get the value minus 3.54. Okay, so here we have to put a conclusion. What is the conclusion is? We have to compare this value with our standard value. That is, our standard value is 2.33. So while comparing the test statistic, that is the calculated value of Z and the table value of Z, what is the result we are getting here is, since the 3.54 is not less than 2.33, we are going to reject this hypothesis. So the final result is we may support the claim of increase in the braking system. Okay, the next sum is, an insurance agent has claimed that the average age of policy holders who insure through him is less than the average of all agents, which is 30.5 years. A random sample of 100 policy holders who had insured through him revealed the mean and standard deviation are 28.8 years and 6.35 years respectively. So test this claim at 5% level of significance. So here the value of n is given, what the value of n is given is 100, and mu, that is the population mean, is 30.5, and the standard deviation is 6.35, and the sample population is 28.8, and our level of significance is 5%. So first step, the step is the null hypothesis. We are going to fix our null hypothesis. The null hypothesis, what we are fixing here is H naught is mu is equal to 13.5, what is given by the sum. And the alternative hypothesis is mu is less than 30.5. So we are taking a left tail test here. We are going to consider one tail test. So the alpha here given is it's 5% level of significance. So the value of alpha is 5%. So critical region, what we are going to do here is we have to compare our result with minus 1.645. The test statistics, what we are going to use here is x bar minus mu divided by sigma by root 10. So the x bar value is 28.8 minus the mu value is 30.5 divided by the value of sigma is 6.35 divided by root of n value is 100 is equal to the value what we have found here is minus 2.68. So the conclusion here is we have to compare our calculated value with our standard value. So while comparing the standard value, what we have got here is minus 1.645 is not less than minus 2.68. So the final result what we are going to do is we are going to reject our null hypothesis. So previously we have seen about the testing of hypothesis for a single mean. Now we are going to see about the testing of significance for a difference of mean. So what is the significance of difference of mean is, we are considering here x1 bar be the mean of a sample of size n1 from a population with mean mu1 and variance sigma 1 square, and let x2 bar be the mean of an independent sample of size n2 from another population with mean mu2 and the variance sigma 2 square. Okay, so the standard normal variate z corresponding to x1 bar minus x2 bar is given by z is equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So this is the formula we are going to use for test statistics in the test of significance for difference of mean. So here, if the samples are taken from the same population with the standard deviation sigma, then the sigma 1 square and sigma 2 square will be equal to sigma square. Then the test statistic will become z is equal to x1 bar minus x2 bar divided by sigma into root of 1 by n1 plus 1 by n2, or x1 bar minus x2 bar divided by root of sigma square by n1 plus sigma square by n2. So now we will see some problem under test of significance of difference of mean. So in a random sample of 500, the mean is found to be 20. In another independent sample of 400, the mean is 50. Could the samples have been taken from the same population with standard deviation 4? Okay, so what is given here is the value that is one sample, that is sample size is from one population is n1 is equal to 500, and from another population is n2 is equal to 400. And the population sample from then the population mean from one sample is x1 bar is equal to 20, and the population mean from another sample is x2 bar is equal to 15. So these are the values given in our sum. Now first step we have to fix our null hypothesis. Here we are going to fix our null hypothesis as H naught is such that mu1 is equal to mu2. That is both the means from the population are same. Okay, and the standard deviation what is given here is 4. So samples have been taken from the same population of standard deviation 4. Okay, so here the standard deviation is for both the populations, from one population and another population is the same value. They have given the same standard deviation for both the populations. So now we are going to fix our alternative hypothesis. Here for null hypothesis we have taken it as mu1 is equal to mu2. So for alternative hypothesis we are considering here mu1 is not equal to mu2. This is our two-tailed test. Okay. So the next step is our test statistics. So here, since it is the difference of mean, because the samples are taken from the two different populations, we are using our difference of mean concept. So our test statistic here is Z is equal to x1 bar minus x2 bar divided by sigma into root of 1 by n1 plus 1 by n2, because here we are using sigma since the standard deviation for both the population was same. So which is equal to here the value of x1 bar is 20 minus the value of x2 bar is 15 divided by the standard deviation is 4 into root of 1 divided by the value of n1 is 500 plus 1 divided by the value of n2 is 400. So while calculating this, we will get the value as 18.634. Okay, and after that we have to compare this with our standard value. So here they have not given any level of level of significance. So we can choose our own level of significance. Either you can choose 1% or 5% or 10%. Most probably here we will choose only 1% and 5%. So in this sum we have considered our 1% level of significance. So our standard value for 1% level of significance is 2.58. So the calculated value 18.634 is greater than 2.58. So our result is we are going to reject our null hypothesis. Okay, the next sum. A storekeeper wants to buy a large quantity of light bulbs from two brands labeled 1 and 2. We bought 100 bulbs from each brand and found by testing that brand 1 has mean lifetime of 1120 hours and the standard deviation of 75 hours, and brand 2 has mean lifetime of 1062 hours and standard deviation of 82 hours. Examine whether the difference of mean is significant. So here the sample from one population is n1 is equal to 100 and from another population is n2 is equal to 100, and the population mean x1 bar is 1120 and the population mean x2 bar is 1062, and the standard deviation here is s1 is 75 and s2 is 82. Okay, so the null hypothesis, the first step we are going to fix here is we are taking our mu1 is equal to mu2. Okay, so that is a different, that is the difference of mean is insignificant. That is there is no difference between the two populations. Okay, so alternative hypothesis here we are going to fix here is mu1 is not equal to mu2, so it is a two-tailed test here. So the test statistic is Z is equal to x1 bar minus x2 bar divided by square root of s1 square divided by s1 plus s2 square divided by n2, because there are two standard deviations given here. So which is equal to the value of x1 bar is 1120 minus x2 bar is 1062 divided by root of the value of s1 is 75 the whole square divided by 100 plus the value of s2 is 82, the 82 the whole square is 6724 divided by, here the n1 and n2 value is 100. Okay, so by calculating this we will get the value as 5.219. Okay, so now we are going to compare this with, here also there is no level of significance given, so you can choose by yourself either it is 1% level of significance or 5% level of significance. So here we are considering a 1% level of significance. The standard value for 1% level of significance is 2.58. So comparing our calculated value with the tabulated value, here the 5.219 is greater than 2.58. So we are going to reject our null hypothesis H0. So this is the sum for difference of mean. Okay, so next one we are going to see about the test of significance of proportion. Okay, so the test statistic what we are going to use here is Z is equal to P cap minus P divided by root of P into 1 minus P divided by N. Okay, so P cap is nothing but our sample proportion and P represents our population proportion and N is a sample size. So for test statistic we are going to use this this formula for single proportion. So we will see one of the sum for a single proportion. College management claims that 80% of all single women appointed for teaching job get married and quit the job within 2 years of time. Test this hypothesis at 5% level of significance if among 200 such teachers, 112 got married within 2 years and quit their jobs. Okay. So now here the sample what they have given here is n is equal to 200. So the number of teachers who got married within 2 years and quit job is 112. So that is your x value, and P is the sample proportion of teacher quit the jobs. So out of 200 teachers, 112 teachers they have quit the job. So 112 divided by 200 is equal to 0.56. That's the value of our P. Okay. Now we are going to fix our null hypothesis, that is H naught is equal to, that is H naught P is equal to 0.8. So they have claimed that 80% of all single women are appointed for teaching job. So 80 divided by 100 is nothing but 0.8. So the value of P is 0.8 is the proportion of teachers got married within 2 years and quit jobs and have Q is equal to 0.2. That is Q is nothing but 1 minus P. Here the P value is 0.2. So the Q value is 1 minus 0.8 is 0.2. Okay. So the alternative hypothesis is, so they have given that P is equal to 0.8. This is what the college management claims. So now we are taking that it may be greater than 0.8. So that is it may be greater than 80%. So H1 is P is greater than 0.8. So we are going for our single tail test. So the test stack is here is Z equal to P minus P divided by PQ divided, root of PQ divided by N. So the value of small p here is 0.58. This is the sample. So it is 0.58 minus the capital P here is 0.8 divided by root of, and the P value is 0.8 into, and this Q value is 0.2. So divided by the value of N is 200. So we will get, so while subtracting 0.56 minus 0.8, we will get minus 0.24. And the calculated value of root of 0.8 into 0.2 divided by 200, it is 0.028. Okay. So the final value what we are getting here is minus 8.57. Okay. So the significant value here we are considering the 5% level of significance. So the right tail test for 5% level of significance is 1.645. So comparing the calculated value with the standard value, so 8.57 is greater than the 1.645. So we are going to reject our hypothesis, right? So next one what we are going to see is the difference of proportion. Okay. So difference of proportion here is we are taking, there will be two populations and we are considering two proportions. That is from population 1, the proportion we will denote here is P1 and the sample size is N1 and the proportion value is P1 cap, that is the sample one. For population proportion it is P1, for sample proportion is P1 cap. Similarly for population 2, the population proportion is capital P2, size is N2 and the sample proportion is P2 cap. The test statistic what we are going to see here is Z is equal to P1 minus P2 divided by root of PQ into 1 by N1 plus 1 by N2. Okay. So here the P1 formula is X1 divided by N1 and our P2 formula is X2 divided by N2. Okay. And if you want to find P cap, the formula here is N1 P1 plus N2 P2 divided by N1 plus N2. Okay. So from this we know that is if you multiply N1 into P1, so N1 into P1, you will get X1 is equal to P1 N1. So instead of N1 P1, we have written it as X1. And similarly, if you can calculate X2 from here, you will get N2 P2 as X2. So instead of X2 P2, we are writing it as X2. Okay, so X1 plus X2 divided by N1 plus N2. Even if you know these values, we can calculate our P. Okay, we will see the sum in the difference of proportion. In a referendum submitted to the students' body at a university, 850 men and 566 women voted. 530 of the men and 304 of the women noted yes. Does this indicate a significant difference of opinion on the matter at 1% level between men and women students. Okay, so now they given our N1 as, that is 850 men, it is the N1 value, and our X1 is, out of that 530 men as given voted, so X1 is 530 and our N2 is 566 and our X2 is 304. That, okay, so next we are going to fix our null hypothesis. Our null hypothesis here they have given it as P1 is equal to P2 equal to P, that is there is no significant difference of opinion between men and women. So the alternative hypothesis we are considering here is P1 is not equal to P2, this is our two-tailed test. So our proportion P1 is proportion of men favoring the referendum in the sample, that is X1 divided by N1. X1 value is 530 and our N1 value is 850. So the value of P1 is 0.624. Similarly, P2 is the proportion of women favoring the referendum in the sample, X2 divided by N2. The value of X2 is 304 divided by the value of N2 is 566. So the P2 value is 0.537. Okay, now we are going to use our test statistic. Z is equal to P1 minus P2 divided by root of PQ into 1 by N1 plus 1 by N2. So the value of P1. So here we have to find the P cap and Q cap value. So in order to find the P cap value, we are using the formula N1 P1 plus N2 P2 divided by N1 plus N2. As I said in the previous slide, we know that N1 P1 value is X1 and N2 P2 is equal to X2. So X1 plus X2 divided by N1 plus N2. So the X1 value is 530 plus 304 divided by 850 plus 560. That is the N1 N2 value is 850 plus 566. So out of this we will get 834 divided by 1416. So the value of P cap is 0.589. Okay. So we know that P is equal to Q. In order to find the value of Q, it is 1 minus P. So here we have to find the Q cap. So Q cap is equal to 1 minus P cap. So the value of P cap is 0.589. So 1 minus 0.589 is 0.411. Okay. So now we have to substitute the values in our test statistics. So Z equal to 0.624 minus 0.537 divided by root of 0.589 into 0.411 into 1 by 850 plus 1 by 566. If you calculate, we will get the answer of 3.259. So here we have considered the two-tailed test. So we have to compare our standard value with 1%. They given the level of significance is 1%. So the standard value for 1% is 2.58. The calculated value what we have found here is 3.259, which is greater than our standard value. So here we are going to reject our hypothesis. Okay, so till this we'll see in this video. Next we'll continue the next video. Thank you.